know. So the ball rolled 1 unit of distance in the first second, and then in the second second it rolled 3 units of distance. And so in the first 2 seconds together it had rolled a distance of 4. And then between the second second and the third it went a distance of 5, so now the total's up to 8. So this is the same sequence that we saw in the previous class. We were talking about these triangles, and it's the same thing. I'm going to go over here to my document camera and do some writing. Just a second. So n is going to be the number of seconds. Okay. And A, well, I could use a different letter. Well, let's use D for the distance. dn is the distance traveled after n seconds. So if n is 1, then dn, or d1, is 1. And then d2 is 1 plus 3. And so forth. So Galileo's first step was to say, I think the distance increases by 2 units every second. Okay, let's get a show of hands. Are you yes, no's? So yes, no's. Was that deductive reasoning? Yes or no? Wonderful. The count's going up. So far, 8 no's and 0 yeses. So great, you guys have got that. So inductive reasoning Now, then Galileo said, if that's true, then the distance dn is n squared. Is that inductive or deductive reasoning? Right, put up yes if that is, put up yes if you think it's still inductive reasoning. Put up no if you think it's not. Not. Cool. Oh, we got it, okay. And what makes it deductive, if you were not here in our previous class meeting, what makes it deductive is that I proved that the sum of the first n odd numbers is n squared. And so that was just kind of a logical argument. Okay.
Could you move the paper a little to the side?
Thank you. Yeah. Oh, yeah. Let's see. Yeah. Okay. Yeah. So
actually, Fred, could you move it back a little bit more to the right? Because now we can't see the first half.
Oh, now your window must be. Oh, I know what's happened. Aha! I got it. Is it better now?
Yes.
Okay.
Thank you.
Yeah. Okay. So what I just wrote for the audio transcript that's being made as it's being recorded is, if that's the rule, that the distance increases by 2 units each second, then the distance is n squared, and that's deductive because last class I proved that the sum of the first n odd numbers is n squared. Okay. Now, if the time a ball is allowed to roll on an inclined plane is doubled, what effect does this have on the distance that the ball rolls? First off, let's go in the private chat. And I'm trying to get all this feedback to substitute for the facial expressions in a classroom. Put in an answer. What would happen if if you double the time that the ball rolls? So you roll this amount of time versus twice as much time. What happens to the distance? Anybody put something in the chat, either the private chat or the public chat, I don't care. Uh-oh. Well, let's do it. We can do that problem two ways. They are saying use inductive reasoning, so let's do that first, but now we can do it either way. If we believe the n squared thing, which was based on inductive at the beginning. But look, if you roll 1 second, you go 1. You double that, you go 2 seconds. Now you've gone 4. If you double that again, 2 seconds versus 4 seconds, doubling the time. What happens to the distance? Oh, okay, good. I'm starting to get some conjectures in the private chat. That's nice. You're thinking about it. Okay, let me write some things. People are asking for this to be a little bigger. Okay. So when n was 1, dn was 1. When n was 2, dn is 2. No, dn is 4. I'm going to keep doubling. If n is 4, dn now is 16. What if n was 8? Then we have to add the first 8 odd numbers, 1, 3, 5, 7, 9, and so forth. We get n squared. We get 8 squared, right? 64. It looks like every time I double the time, I'm writing times 2. What happened to the time? It was times 4. So based on the examples we've got so far, we think that when you double the time, you quadruple the distance. Now that's an inductive conjecture based on the examples that we have so far. Okay, now let's take a deductive approach to the same problem. let's take it as a given if the distance is n squared, then what? So what if I go, instead of going n number of seconds, I go for a number of seconds twice as much, 2 times n? What if I go that many seconds, whatever number n might be? Now, the formula is saying you take the amount of time and you square it. So you take that 2n and you square it. And then you do the algebra, 2n times 2n. You can't see that? Let me slide it up. Okay, you get 4n squared. So that's 4 times as much as dn. d2n is the same as 4 times dn. All right. So the point that textbook is making with this series of examples is that to do really good problem solving, you're going back and forth using both kinds of reasoning. And I think that's what they're getting at. So you want to recognize which kind you're doing and deliberately use both. Number 22. If the time a ball is allowed to roll on an inclined plane is tripled, what effect does this have on the distance? Twice the distance made 4 times, twice the time made 4 times the distance. So now the question is, okay, if you do 3 times the time, what happens to the distance? Somebody want to unmute and just say something or tell me how you're thinking about it? So twice the time made 4 times the distance. Where did the 4 come from? See how I did 2n times 2n and I got 4n squared? So when the time was just n, the distance was n squared. But you make twice as much time, 2 times n, and you got 2n squared. I'm getting lots of guesses, but I'm not getting any right ones. What if it wasn't twice? What if it was a 3? See where I'm pointing? What if that was a 3? Then what would you get? No, 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 no. Okay. Okay. I think if I get rid of variables for a minute, maybe the letter n is hard to interpret. Now I've gotten I've gotten would you squared, I've gotten 3 times the distance cubed, I've gotten maybe 6 times, I've gotten 3 times, and I've gotten stayed the same. And now I got an 8, and no. Okay, that's, I'm going to get the letter N out of there. Let's do this thing with some numbers to start with, okay? Then I'll put the N back. All right. Okay. Yeah, I know some of you guys maybe just you had algebra in high school and maybe it's been a long time ago, and then so I put the variables in there, and you don't know my meaning. It's not that the meaning is complicated, I think. It's you're unfamiliar with the notation, but here we go. Okay. So if I compare if the distance is 1, the time is 1 versus 2 times 1, double the time. What if the time was 3 versus doubling that? I'm comparing 2 different amounts of time, and one of them is twice as big as the other. I want to see what's the effect of that. So for 3 seconds, it was 9, but for twice 3 seconds, for 6 seconds, it was 4 times 9. So now, this is the chart for doubling the time. I've done like 3 examples, and then I'm going to make a line for the general case. And then I'm going to do this with tripling the time, because we're getting the wrong numbers for number 22. Okay. So now here's the general case for doubling. Not necessarily 1 or 3 or 5, but just any old number n versus 2n twice as much. Well, I wrote, okay. Now, so this was a chart for doubling the time. Now let's do tripling. So just like I did with doubling, I'm just using 1, 3, and 5 as examples for the amounts of time. And I'm comparing each one with what happens if I triple it. Okay. So you compare 1 squared versus 3 squared, it's 9 times bigger. Okay? Now let's do the amount of time is 3, or 3 times bigger, 9. Compare those two. So we get nine times bigger. Do it with 5. So we go 5 seconds. The distance is 25 units. But if you go 3 times more, 15 seconds, it's 9 times 25. 9 times bigger. If you go any old amount of time in versus 3 times as much, you're looking at n squared for the time versus 9n squared. So you see, if you, however amount of time you rolled, compare that with rolling 3 times longer. What's the difference? You go 9 times the distance. Yeah. Let's see. I kind of want to see a show of hands now on the yes, no. Are you understanding now? I need to see a lot of hands because I'm not going to say your name or anything. I just, or you can put in the private chat if you want to, you know, a yes or a no or a kind of. What would really be cool is if somebody could ask a question. You want to put your hand up because you might not know exactly what to ask, but we go back and forth a little bit. You know, if I can figure out what you're thinking, then we can get there. Anybody want to, could you put your hand up and we just have a little bit of conversation? I got, in the private chat, I get a lot of kind of, and, you know, getting there. Yeah, somebody asked a question in the chat. If the time was quadrupled, would the distance be 6 times 16? Yes, it would. Right. Oh yeah, let's see, a student. Emma Cobb, you have your hand up.
Yeah, I was just wondering, like, is there like a formula for it, like when you double the time and stuff, or do you have to like go through all this math to find out every time? Because it looks like it's like 2 and then times 9 for
Yeah. Yeah, so the distance that you travel in these units. We don't know how much a unit is, maybe 6 inches or a foot or something, but the number of units distance that you travel is the square of the time in seconds.
That makes sense.
Now, in what I was just doing here, yeah, but,
But could you write the formula on the paper?
well, yes, one moment. So let me try. I want to make sure we get the structure, the flow of the big picture. Okay. Galileo rolled these balls down the ramp. He measured the time with his pulse. He got these examples: 1 second, 1 unit, 2 seconds, 4 units, 3 seconds, 9 units. And he says, based on what I've seen so far, the distance that you go, in each second that you roll, you go 2 units further. You know, the first second it was 1, and then it was 1 plus 3, and then it was 1 plus 3 plus 5. Each second you're going faster and faster, so you roll at 2 units more distance in each 1 second period. So he says, by inductive reasoning, I think that's the rule. It's 2 units added for each second. Then deductive reasoning, he says, well, if that's true, if I'm just adding up 1 plus 3 plus 5, and then 1 plus 3 plus 5 plus 7, and so forth, if that's the rule, then the distance is n squared. It's going to go 1, 4, 9, 16, so forth. That's from last class. Okay. So now we think we have the rule. Okay. Now there are 2 different approaches that we could go with to address what happens when you double the total rolling time. Inductive approach, just make a table. If the time is going 1, 2, 4, 8, the distances are 1, 4, 16, you quadruple. You're with the argument up to there. Inductively, you see why you think when you double the time, you quadruple the distance. Okay. And then, we say, you know what? If that n squared was the formula, that's why it'll logically make it. So if you double the time, you quadruple the distance. Because if you replace some amount of time in the formula, you replace that with twice as much, 2n, whatever n might be, 1 second, 3 seconds, 5, whatever. If you replace the n with a 2n and simplify, you get 4 times as much as you would have had from just plain n. To double the n, replace the n with a 2n, and you replace the distance, the n squared, with 4n squared. So that's a deductive argument that you double the distance makes you quadruple the time. Okay. So then they ask us, well, what if you had tripled the time? What if you had put a 3 here? You're comparing n number of seconds versus 3 times as many seconds, 3n. You know, to get the distance, either way, you're just going to square it. So what happens, what's the difference, you know, compare n squared versus 3n squared. And so, you know, I went through all those numbers. I don't have to go through all the numbers. but I don't think it completely communicated the first time through with just the letter. So I'm trying to show you what I mean. If I roll for n number of seconds, the time is n squared. If I roll 3 times as long, 3 times n, whatever n was. See, now it's 9 n squared instead of just n squared, so 9 times bigger. And so I don't know if doing those tables with all the numbers made it better or worse. I did the table with the numbers because I think you look at the letter N and then you look at the 3N and you say, what's that? Well, I mean like 1 second versus 3, or 3 seconds versus 9, or 5 versus 15, or whatever versus 3 times whatever. It's that using an N to stand for whatever that sometimes is confusing. I'm going to clear all. Did that last little spiel in response to the question help? Give me a yes or no. Or maybe I can see some more faces. I can't see the participants window right now, but if I was in class, I'd just see all those unhappy people or smiling people one way or the other, and then I'd know. Well, I got like, one person showing their face. She's happy, but okay. Let's put up some yeses. Did that help? Well, let me ask. Okay, let me be more specific. Do you see that if you square a number, you're going to get one thing, and if you square the 3 times as much, it'll be 9 times bigger? Just that? You see that? Mm-hmm. It's 11 yeses. Not any no's. And so I can't tell whether that's just silence or real understanding. So that leaves 8 students who might or might not. Okay, I'm gonna need to end the session anyway because it's getting late. You can get me on the individual Zoom session. I'm showing you the homepage over here. You go into ConferZoom, which usually works. I think why it broke on Tuesday was I tried to do it as the test student. I have this fake student account, but that person has no email address or anything, and so okay. So anyway, you click on ConferZoom and you go to appointment booking. And there are these blocks, and you can click on there and reserve a block of time to meet individually. Okay, I'm going to stop recording.